Alrighty, guys, so we're going to continue on with our unit of parallel lines, and it seems kind of a off stretch that we're going to go into triangle territory. The reason that I'm including this in here is because what we just learned about parallel lines you can use to prove this first angle theorem about the interior angles of a triangle. The second theorem we'll talk about is an extension of the interior angles. It's kind of related. It's about the exterior angle of a triangle. And so I just throw it in here. But when we get to our actual triangles unit, you will see this again. Okay, so you kind of get two doses of this, and it's fun because I get to show my favorite corny video for this. So this is one of my personal favorites to teach. But okay, and I will post a link for that funny video for you all to enjoy my cheesiness. Oops, sorry. Okay. So we're going to start with the interior angle theorem of a triangle. So here's a triangle, three angles A, B, and C. The sum of the measures of the interior angles equals 180 degrees. That is the interior angle theorem. So we say that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. Okay, that is so huge. I want you to commit this to memory. You need to memorize this. You add all three angles in a triangle up, it equals 180 degrees. This comes up a lot from here on out. Okay, even in part B of geometry, it's going to come up, so you need to remember it. Okay. So let's see how to do this. So we know two angles in the triangle. One is 24 degrees, one is 37 degrees. We want to find the other one. And so if you're going to be super official about it, here's what you would do. The measure of angle 1, which is what we're trying to find, plus, and then we'll add the other ones. We'll say add 24 and add 37, and that should get you 180. And then we would combine like terms here. And then subtract 61. And you should get 100. Whoops, I can't subtract. That's bad. 119 degrees. So that's the like official way to do it. But honestly, I'm perfectly fine if you just do 180, subtract 24, subtract 39. I'm perfectly okay with that. In fact, when I'm doing any kind of assessment or anything or a test, that's what I do. Like I'm having a time with this camera, y'all. There we go. Sorry if it's a little wonky. Anyway, but that's really it. I mean, that's the gist of it. You know, two angles, you have to use the 180 to subtract. You add the two up, subtract it from 180 to get the third. That's really what you're doing. Okay, this one's a little bit more complicated. There's actually three separate triangles here, and we got to find angle 1, 2, and 3. I'm going to write those out over here so I can keep track of them. I'm going to write that a little bigger. All right, and then down here, I'm going to show where we'll get these from. So angle 1, notice, is right here. That is inside this right triangle right here. And so we know one angle is 90, one of them is 43. So we can simply do 180, subtract 90, subtract 43. And if you type that to a calculator or do it in your head, you'll get 47 degrees for angle 1. Angle 2 is a little bit of a different story. Notice that it's right here adjacent with the 43. And so I'm noticing that those two, if I draw this, those two are a linear pair. So when you add their measures up, they should get you 180 degrees. Okay, you could also think of them as being supplementary. And so supplementary is the 180, and so I'm going to subtract the 43. That will get me the angle 2, and when I do that, I end up with 137 degrees. Now, notice angle 3 I just thought of this. There's actually a couple different ways you could get this, but the way that I first thought about it was that we know that angle 2 now is 137. Angle 2 and this little itty bitty 12 degrees down here, they make this skinny obtuse triangle right here. And so we could do 180, subtract the 137 we just found at angle 2, and subtract the 12 that we were given, and you do that, you'll get 31 degrees. Now there's another way you could do it using the angle 1. If you notice, this is a bigger right triangle that I'm outlining here. And so we know that this angle is 90, and we know that angle 1 we just found to be 47. Let's do it this way. You still start at 180. We'll subtract off that 90, and then we'll add these two together to make one big angle that'll be part of this bigger triangle. So 47 plus 12 would be 59. And that will get you to 31. So notice that's actually two different ways to get the measure for angle 3. I think most kids see this first way that I did, and I just saw this as I was doing this video. So I threw it in for you. Okay. So now here's where the actual meat of the lesson is. I'm going to give you a triangle, and all three angles are going to have expressions in them. And so we will use this fact to solve for x and then find every angle measure. All right, now I'm going to scoot up a little bit so I have some room. So just go around and start adding. So I started up here with 9x plus 3. And then I came down to 5x plus 2, or 5x minus 2. And then add the 11x minus 21. All of that equals 180. And I start combining. 9x, 5x, and 11x should give me 25x when you add it together. And then 3 subtract 2 subtract 21. When you evaluate all that, that should give you minus 20. And that equals 180. Now we're going to add 20. $180 plus 20 is 200. And now we'll divide 25. And 200 divided 25 should be 8. Right, that's the first hurdle, is to get what x is. If we can't get what x is, we're going to be having some issues. Okay, so now to find each angle measure, notice every angle has an x in it, and so we have to go substitute the x back in. So if I start here at angle D equals 5, substitute the 8 in for x, subtract 2, evaluate that to be 38 degrees. So the measure of angle E would be 9 times the 8 plus 3, which should give you 75 degrees. And then measure of angle F, 11 times the 8 is minus 21. That's a terrible 21. And you evaluate that, you get 67 degrees. Ooh, just barely fit it in. Okay, and if you add these up, 38, 75, and 67, they do indeed get you to 180. I checked earlier. So we know we did the problem right. Okay, let's do another one. So same exact thing, just different expressions. So 4x minus 22 plus 10x minus 4 plus x plus 11 equals 180. Combine our x's, 4x, 10x, and x gives you 15x. Negative 22 minus 4 plus 11 all combines to be minus 15. That's going to equal 180. Now we'll add our 15. 15x is going to equal 195. Divide 15, and x should be 13. All right, now we have to go substitute back in. So the measure of angle P, 10 times 13 minus 4, that's going to give you 126 degrees. Measure of angle Q, 4 times 13 minus 22, and that should give you 30 degrees. And the measure of angle R is going to be 13 plus 11, which is 24 degrees. 24. And if you add up 126 plus 30 plus 24, that does get you to 180. So you know you've done it right. Okay, that's the interior angle theorem. So I need to commit to memory. You add all the angles up in a triangle, it equals 180 degrees. And you can use that to find one angle. When you know two of them, you can find the third one. Or you can set up these equations to solve for x and then go back and find the measures. All right, now let's literally flip the page and talk about the exterior angle theorem. So, in case you don't realize or know, an exterior angle is when you have a triangle and you just extend one side, and that forms the exterior angle. And that means it's outside of the triangle. So the exterior angle is equal to the sum, remember sum means to add, of the two remote interior angles. And I added in for you that remote means the non-adjacent. So in other words, angle 1 is our exterior angle. And then 2 and 3 would be those remote interiors. They're in the basically the opposite corners from where the exterior is at, okay? Opposite corners. You add the opposite corners up, it's supposed to equal the one outside. So the measure of angle 1 is supposed to be the measure of angle 2 plus the measure of angle 3. Okay, and same idea. You could know these two, add them up to get that one, or you can know the outside one and one of them inside, and you're trying to find the third one. Okay, that's what we're going to look at down here. Let's scoot up a little bit. I know on the bottom I'm going to need room. Okay, so look at where our indication's at. We're indicated right here on the outside. This is the exterior angle, and we know both the corners, so we literally just add them up. So the measure of angle 1 is supposed to be 76 plus 52. You add those together, you get 128 degrees. All right? Pretty simple. There we go. It's a little out of focus. All right, we're looking for this one. Notice it's the interior this time. It's on the inside of the triangle. So we have to manipulate this a little bit. We know one of the insides and we know the outside. We're trying to find the third one. And so what we'll do in this case is you take the outside, the 104, subtract the corner that you know. And that will get you the corner that you're looking for. In this case, 25 degrees. Right? This is the basic idea. You either know both corners and add them up to get the outside, or you know the outside and one corner. You're trying to find the other corner. Right? The next level of this is, again, you have expressions. And so you'll set this up and solve for x. And we're going to find each angle measure. And I mean every angle measure, including this one right here that's blank. We will find that one. But I'll show you how to do that. Okay, I always start with the one outside because that's what it says to start with, so I just start there. So our exterior is 18x minus 15. That equals the two corners added together. So 13x minus 11 plus 4x plus 1. Drop this because we can't do that, anything there yet. Combine over here, 13 and 4x gives me 17x. Negative 11 plus 1 gives me minus 10. Remember, it's usually best practice to move the smaller x, so I'm going to subtract that. That gives me x minus 15 equals negative 10. Now I'll add 15. I'll get x is 5. Okay, there's the first hurdle to get what x is. Now we're going to go substitute it back in for all our x's. Let's get this over a little bit. I know it's getting a little jumbled. I apologize. Hopefully you can spread yours out easier than I can. So angle A is a 13x minus 11. So 13 times the 5 we just found minus 11. And that's going to give you 54 degrees. The other one was at angle B. That's 4 times the 5 plus 1. That's 21 degrees. Now we need to plug into the exterior. Now notice how I'm going to name the exterior. I got to make sure I do completely outside. So that's why they include this extra point out here. That angle is going to be named DCB. That's going to keep you outside your triangle. You could have said BCD if you wanted to, but I just went with DCB. Anyway, so 18 times the 5 we just found. Subtract 15. That's going to be 75 degrees. And notice, if you add 54 plus 21, you definitely get 75. So we've done this correctly. Okay? Now here's the new question. How am I going to find the measure of this, what I'm calling the blank angle here? I need to name that. So I'm going to name it ACB. So how am I going to find ACB? Excuse me. Well, look what we've got so far. I know that this angle up here is 54. I know this one is 21. So I could do what we learned on the front about the interior angles, is that this one plus these two are supposed to equal 180 degrees. And so I can do 180 subtract 54 subtract 21, and that's going to give me 105 degrees. Sorry, it's on the very edge down there, but another way you could think about it, just thought of this too. You just found this one a minute ago. You know that it's 75 degrees. And this angle and this one, those two are a linear pair. So together they are supplementary. So you could do 180 subtract the 75. That also gets you 105 degrees. But in the end, for this blank angle here, because you could be asked to find that, I'm just saying, you could be asked to find this extra one right here. You have options. You can do the 180, subtract the 2 on the inside, or 180, subtract this exterior, and that will get you the inside one. All right? Let's do it again. So the outside, start there. 9x minus 8 equals the 2 on the inside added together. So 5x subtract 27 plus 7x minus 32. Bring this down and combine on the right side. So 5x and 12x. Oops, sorry, 7x gets you 12x. Got ahead of myself. Negative 27 minus 32 is minus 59. Let's move the smaller x. So negative 8 equals 3x minus 59. Now because of my x's are over here, got to move the 59. So 51 equals 3x. Now we'll divide 3, and we'll get x to be 17. Okay, now we're going to go plug the x back in. So the measure of angle J, because that was where one of our x's was at, 5 times 17 minus 27. You evaluate that and you'll get 58 degrees. The measure of angle K, that is a terrible K. I always have trouble with my K's. There we go. 7 times the 17 minus 32. You evaluate that, you'll get 87 degrees. Now let's name our exterior. So notice it's on the complete outside, so I'm going to go with the name KLM. That's going to keep me outside. So KLM. 9 times 17 minus 8. And evaluate that, you'll get 145 degrees. And if you add 58 and 87, you get back to 145, so we know we did the problem right. Now let's find this angle right here. That's going to be named, I'm going to call it JLK, just for me. You can name it other things. So JLK. I like to use the 2 we just found a minute ago. So you can do, actually I did that over here. Okay, so remember on this one I did 180 subtract the 2 on the inside, so 2 corners. But I also said you could do 180 subtract the exterior you just found, because these 2 are supplementary. I'm going to do that here. So we found our exterior to be 145, so I'm going to subtract that off, and you'll end up at 35 degrees. Which you should get also if you do 180, subtract 58, subtract 87. You'll get to 35. All right, that's all I have. I think this is pretty easy. I hope it's pretty easy for you all. I mean, I think I feel like I did okay presenting it to you. It should be an easy topic to figure out. But anyway, so make sure you watch this video lesson in its entirety. And if you want to watch the cheesy video, you can. I think I like that it's cheesy. I'm also going to try and find a video link and post it for the proof of the interior angle theorem, so you can see how the parallel lines are used to prove it. You don't have to watch it if you don't want to. It's just a freebie. And then you have a digital homework assignment. So make sure you get all that done. And if you have questions, please let me know.